A hydrograph is usually set up at a gauging station of a river to monitor water flow for flood control and risk management. It monitors and shows how a river's discharge, measured in cumex, changes over time after a rainfall event. The amount of rainfall is represented by a vertical bar chart you see on the left of the diagram. Now, let's walk you through the main features of a hydrograph. Discharge is the volume of water flowing past a point in a river each second, measured in cubic meters. Notice that discharge starts above zero, even before the storm. This baseline level is called baseflow. It makes up the portion of a river's discharge that comes from groundwater slowly seeping into the river, and it reflects how wet the basin already is before rainfall. In wetter seasons, baseflow is higher. In dry seasons, it is lower. When rain begins, water first soaks into the soil. As the ground becomes saturated, more water flows directly into the river. Later, as the rain intensifies, discharge in the river starts to rise. This is called the rising limb. The steepness of this rise tells us how quickly water is reaching the river. A sharp increase means water is flowing rapidly, while a gentler slope indicates a slower rise. The river then reaches its highest point. The peak discharge represents the maximum volume of water flowing in the river during the storm event. The time gap between peak rainfall and peak discharge is called the lag time. Short lag times mean water reaches the river very quickly, while longer lag times show delayed flow through the basin. After the storm ends, less water enters the channel. Discharge begins to fall. This downward section is the falling limb or recession limb. If you're studying freshwater more broadly, my full freshwater video, where I go through all of this in exam detail, will be coming out very soon. To recap the main features, the rising limb shows the amount of water entering the river. The peak discharge shows the maximum amount of water in the river at any given moment. The lag time is the gap between the storm and when the river reaches its full capacity. The falling limb just shows water gradually draining away. In the exams, just remember that the flood hydrograph illustrates how long it takes for a river to reach its maximum discharge, or in simple terms, how fast the river gets full. It also illustrates how long it takes for water levels to return to normal, which is key for flood prediction and management. The most important point here is the lag time. A simple way to remember it: steep limbs peak quick, times brief. The river with a brief lag time floods faster. In steep or urbanized catchments, surfaces are often impermeable. Infiltration is limited, so water runs rapidly into the river. This produces a steep rising limb, short lag time, and high peak discharge, increasing flood risk. However, in flatter, more permeable basins, water infiltrates and is stored in the ground. Flow to the river is slower, creating a gentler rising limb, longer lag time, and lower peak discharge. Humans can also alter hydrographs by changing how water moves through a basin. Deforestation reduces interception and evapotranspiration. With fewer roots and less organic matter, infiltration falls and overland flow increases. As a result, water reaches the river faster, shortening lag time and raising peak discharge in much the same way as urbanization.